Welcome to Precalculus Concept 23C. We're going to use a radian measure, and I have 4 boxes for you. Okay, in the last video we talked about using a degree measure, and most students are very comfortable or have some sort of knowledge of what a degree is. Many students, though, however, do not fully understand exactly what a radian is. Now, there are 2 ways that we can measure angles. One of them is degrees, the other is radians. And the radian way is actually a way more natural approach to understanding what angles are. So here is my visual definition of what a radian is. Let's say, for example, I have 2 circles. On the left-hand side, I got this little smaller circle, and on the right-hand side, I have a bigger circle. Let's go ahead and put the center of each circle in, okay? I'm doing my best here to sort of guesstimate. And let's go ahead and draw in our initial ray, okay? You'll notice that the radius of the circle on the right is a little bit bigger than the radius of the circle on the left, okay? Here's what we're going to do next. We're going to take this length, and we're going to call this length R on both of them, okay? And we are going to then draw the radius perpendicular to itself, tangent to the point of the circle. So what I mean by that is if I copy the length of the radius like this, okay, now notice that those are different lengths, right? So I should call this actually R1, and I'll call this R2, okay? R2, and this is going to be R1. Here's the idea. We're going to pretend for just a moment that that second ray that we've drawn right here is like a piece of spaghetti, and we're going to actually bend it back onto the circumference of the circle. So I'm going to bend this back on. It would end up right about there. So I would then, if I could like pretend this was a piece of spaghetti and bend R1, it would be there. If I could do the same thing here to the best of my ability to bend this back here, and I would then, I would have covered that much of the circle along the circumference. So here's the cool thing. If you draw that angle from the initial ray to the tip of where it ends up being, no matter the size of your circle, the angle that you create will always be 1 radian. So this angle that you create is called 1 radian. All right, 1 radian, both of them. So it does not matter the size of the circle that you use. 1 radian will always be the same measure. So the true definition, the book will say 1 radian is the measure of the central angle of a circle that intercepts an arc in equal length of radius of the circle, yada yada yada. All it really means is that if you take the same radius and you walk the same distance along the circle, wherever you end up, if you draw a line back, you have covered 1 radian. Doesn't matter the size of the circle, okay? So you've covered 1 radian like that. Remind me in class tomorrow to tell you like the way my professor in college defined a radian using zombies. That was actually kind of cool. So that's what 1 radian measure is. Hopefully that makes a little bit of sense to you. Okay, let's continue. In box number 2 it says, in general we talk about radians in the following way. So again, if I did that same trick and bent the radius back on, this angle here, this would be considered 1 radian, okay? If I go that same distance again, I get right about here, and this distance, or this angle that I would draw here, would be 2 radians. Again, if I went all the way back around, I get something like this, and then I would get 3 radians. And then it'd be about here, and then if I drew this angle all the way around, that would be about 4 radians. And then this angle here, if I went all the way around again, all the way to there, that'd be 5. And then right there, it turns out that there's not quite 6 full radians. There's almost, there's a little bit more than 6 full radians. And we're going to figure out exactly how many there are. But clearly there are fewer radians than there are degrees, because remember there are 360 degrees, and there's just over 6 radians. So 1 radian is definitely bigger than a degree. So we have 3 things in play here. The 3 things in play are as following on this circle here. We have the radius of the circle, all right? Then remember that the radius of the circle is the same over here no matter what, it's constant. And then we have the distance that we are traveling on the outside of the circle, which we're just going to call S in this case. And then we have the angle that's created, known as a radian, which is we're going to call theta. So look at the 3 variables that we have. We have S, which is the distance along the circumference of the circle that we are traveling. We have the angle created on the inside of the circle, and then we have R, the radius of the circle. And the way that these three things are all related to each other is defined as the following. Every radian measure is just the distance s that we cover divided by the radius. All right? So theta is equal to s divided by r. Consequently, s, the distance that we're looking for, is then equal to r times theta. So both of these, if I just algebraize this and solve for s, are equivalent statements, but this only works when theta is measured in radians. Because after all, that's exactly what we're defining. Theta is measured in radians. So the takeaways from this box are the relationship of s, r, and theta, and then that there are just over 6 radians in a complete circle. Okay, here's an example. It says a central angle theta in a circle of radius 6 intercepts an arc of length 15 inches. What is the radian measure of angle theta? Okay, this is a classic example of the first thing that we need to do when we're learning about radians. So first I'm going to draw a picture, and my radius is 6 inches, all right? Then I'm going to draw, to the best of my ability here, what I think that this distance is of 15 inches, because it tells me that the arc of the circle of length 15 inches is intercepted. So the question that I'm looking for is this angle theta, okay? So what is the relationship between my r value, my theta, and my s? Well, remember that every theta is equal to s divided by r. So the theta in radian measures is going to be 15 inches divided by 6 inches, which gives me 2.5. And everyone says, what does the 2.5 mean? The 2.5 is the radians. So the measure that I'm using, I have found the angle is 2.5 radians. Okay, you try. Here's another example for you. A central angle theta in a circle of radius 12 feet intercepts an arc of length 42 feet. What is the radian measure? Okay, the answer is 3.5 radians, but I want to dive into a little bit deeper as to where that comes from. Remember that the circle has a radius of 12 feet, okay? So that means for every 12 feet I cover around the edge of the circle on the circumference, I have covered 1 radian. So there's 1 radian there. If I go another 12 feet, there's another radian there. If I go another 12 feet, there's another radian there. And so far I've gone then 36 feet around the edge of the circle. If I go another 6 feet more, I'll cover 0.5 of a radian more, and I will have the collective 42. So therefore, if I add this up, 1, 2, 3, 3.5, that's what that means by the radian measure. That's where the 3.5 comes from. Hopefully that makes sense to you.